Hello everyone. So it's been a while since our last live session, but now things are a bit more in order, so we decided to start the streams and live sessions again. A few small announcements before we start. So first of all, I wanted to thank everyone who still stays with us and still keeps learning with us because right now we have more than 1,000 subscribers, and I'm really happy about that. Me and my colleagues we will try to post more interesting and educational content soon. So yeah, as I said, we also have been working on some other side projects. One of them is the parametric scripts design market. So now we are going to be updating it hopefully very regularly. So you can find and buy scripts for different parametric design things. Of course, we're going to be also doing a lot of free content like we're doing it now. But if you would like to support us or if you would like to thank us, we invite you to buy something from our parametric design scripts and models store. So yeah, let's. I assume and I hope that everyone is already here. If not, we'll be. I think we'll be starting anyway. So the topic of today's session is some of the advanced mesh techniques, and I've been working on a well, in my opinion, quite interesting project recently, which was related to making 3D models of some corals, some organic shapes for miniatures, for landscape design and things like that. And I thought also for 3D printing, and I thought why don't I show you some of these models and how it can be made. And yeah, so today we're going to be modeling a coral or like a coral reef thing. Of course, there are different types of corals, so maybe we will check others in the next tutorials. Let us know if you'd be interested in. And today I'm going to show you something which is more rock-like, right? So, and of course, the best way to model this mesh in a controlled and a nice way is to make this mesh from scratch. So basically, not just sculpt something weird like dendro, some modifiers, and that's it. This is also a method, but it's not very clean and not very easy to control. Let's say. So, what I'm going to show you today is how to build a mesh from scratch. And also it's pretty much geometry based approach, which I personally really like, and I think is quite consistent and quite logical. So I hope I will try to make the explanation as simple and as clear as possible. So let's start. As you could see from the preview of this stream, we're going to be modeling some really complex organic shape. Maybe I can show you some of the developments that I made. These are the lines of the mesh that we will be trying to get in the end. Of course, it's been adjusted a little bit. Like some of the parts of the base geometry they've been adjusted manually. That's why we won't be aiming for exactly the same mesh. But I will make sure that you have a script which allows you to make not necessarily something like this, but a mesh that you would like to have, right? So let's start from looking at the base geometry. The base geometry is this, let me pronounce it correctly, it's a rhombotruncated cuboctahedron, if I'm not mistaken. Basically, what is it? It's a very simple cube which has been truncated from basically each rib of the cube gets truncated at 45 degrees, right? And yeah, and the resulting shape is basically this piece of geometry. And our coral, our grid, will be built from these two pieces of geometry, rhombotruncated cuboctahedron and a very small cube. So as I prefer to do myself when I find some shape really complicated or if I don't know exactly how to approach it, I just try to assemble it manually. So let's take this shape in Rhino. Let's put two pieces together. As you can see, this cube is all its sides are exactly the same as the sides of this more complex geometry. And as you can see, by simply aggregating these shapes, And I'm pretty sure there is a way to automate this as well. Well, I'm not pretty sure. I know there is a way to automate it as well. There are some plugins like Wasp, like Monoceros, which allow this. But that's not a topic of today's discussion. Still, let me know if you're interested. Maybe I'm gonna make it in the next one of the next sessions. So yeah, as you can see, we start getting quite a solid geometrical grid, right? If we look at it in wireframe, it also gives us quite nice geometry, nice structure. So this is the logics, and now let's start parameterizing it. So I'm gonna hide all the layers, right? So getting distracted. I'm gonna start modeling this very basic shape. So first of all, let's say construct point. Um, let's create a center box because it's probably the simplest way to get it. I'm gonna put 10 as the. We will basically need a cube, right? So all the sides need to be equal. This is our cube. And now it's time to think how are we gonna truncate our cube. Well, as I said, each side will be trimmed at 45 degrees, right? And I don't want to just make it manually like this shape as we already have it here. What was more important is that I want us to be able to control the dimensions and the proportions of this shape. That's why let's do it in a parametrical way. So let's do this. I'm gonna make a very quick and very ugly sketch. Hopefully it helps to explain it a bit better. So maybe not too bit too ambitious of me, but anyway. Yeah, so the strategy will be the following. We take these lines, basically this gives us 45 degrees, right? And if we do the same from the other side, this also gives us 45 degrees, right? And then we do the same from the other side, and it also gives us 45 degrees. So in the end, what we're getting here is a square, right? We're getting a square in the center of each of the faces of our cube, right? So, okay, that's great. Let's say deconstruct brep. Deconstruct brep, right? So we're getting we're getting six faces, right? And then I would also like to get the brep wireframe, right? So we're getting yeah, so we're getting the edges as well, all the edges, right? Okay, great. So then what I would like to do, I would like to take the center. This component can be found in Heteroptera plugin. If you don't have it, let's use the area component. By the way, all the plugins and the links to download all these plugins, they will be also uploaded to our Google Drive, and we'll put this link in the description of this live session. So please feel free to use it and to download it. Yeah, they are all open source. They are all can be found on Futurino, and we will not be using too many of them this time. So yeah, let's say now I have all these centers, right? And well, now what I need to do, I need to scale these squares down to make sure that we get these yeah, these squares here, right? So this is square number one. Let's take yeah, let's set up the scaling factor to something like this, like 0.3 should be fine as well. And then what I need to do, I need to truncate my cube with these they're not going to be squares, they're going to be rectangles probably, like these ones, 45 degrees basically, each edge. How How do I have to do it? Well, let's say what will be the fastest and the easiest probably way to build these shapes for making them truncated. Well, I would say if we build a loft through this edge and we extend it a bit, this is basically our geometry that we need, right? So how can we create pairs of these edges? Well, you see that we have 6 faces here, right? We have 6 separate faces, and each face has a certain edge here. Just so as each of these faces, they also have a certain edge here, right? So this edge and this edge are basically the same as these two edges, which are matching in this case, but they're going to be moved to these positions, right? So how are we going to find the indices of these edges? Now, be attentive to what I'm connecting to what, because I understand this might be a bit tricky. Maybe it's going to be a bit easier to understand once you have this, once we achieve a certain result. So let's evaluate the curves, right, like these ones, the Dirac wireframe. Let's evaluate it. Let's say return price 0.5, right? So we get the centers of these curves, right? And for example, here we have only one curve, right? But if we explode these faces, if we say brep edges, sorry, not explode, we just take the edges of these faces, right? So we get it like that. So you see we have 24 edges, which and here we have only 12, which means that practically 2 of these edges, they are meeting in this point, right? Which is geometrically 100% correct. What we need to change, the only thing we need to change is that right now they are divided into 6 branches. We need to bring them all together. So we say trim tree, right? And then I have to do the same thing as I did for these edges, right? I also need to take the evaluate curve, and yeah, basically we're getting the centers here. Okay, so see, here we have 12 centers, here we have 24 centers. But in one point we have 2 points, right? So what we're doing now, we're saying closest points, right? And we're trying to find 2 of the closest points from each of these points, right? So we say 2, yeah. We're not interested in the points per se, we're interested in the indices of these points, right? Why? Because here we basically have to do the same thing, right? So let me bring a bit more order to the script, so it's also a bit easier to follow, right? So let's do something like this. As I keep saying, and as I keep saying to myself as well, that clean script is essential if you're trying not to get lost in the process. So it's quite important to make sure it's organized properly. At least I'm trying to do it. So yeah, let's see. Okay, so you see that here we have these edges as well, right? And this data structure, this data has the same structure as this data, right? So we have 24 edges, and the corresponding edge in this tree, in this list, basically corresponds with the edge from this list. Which means that now what we can do is to say list item. We connect this component to that tree, that list, we want, and we take the indices from here. So, all right. You see that we're basically getting we're getting how many? 12 branches, and each branch consists of 2 edges. So, if we want to check which edges are these particularly, so to see if we have done everything correctly, you can just build a loft through them. Right? So we take a loft, voila. You see? What is the problem with this thing now? The problem is that these rectangles, they are too short, too narrow, right? We need to make them wider. So it's way easier, instead of extending the surface, if I'm not mistaken, you cannot do it without a plugin in Grasshopper. There is a plugin called I think it's called Wombat, and it's a really good one. Please check it out if you'd like to. But if we assume that we don't have this plugin, we can also do it, and I think it's also going to be a bit probably lighter in terms of computational speed. We can just take these edges and we can extend them, right? So we say extend curve, right? We extend them by a significant length. Let's say we take this maybe, yeah, we take 10, just to be sure that it will be wider than the side of the cube. Yeah, so it's just like that. And also to be sure that if we decide to decrease or increase the size of this cube, it's gonna be adjusted accordingly, right? And then what is also important is to say simplify curve. Uh, yeah, simplify curve. So it gets rebuilt and it keeps basically it keeps only the end points, right? So like this, and now we're getting these lofts a lot longer. Yeah. So yeah, basically now it gets a lot even simpler because we just need to merge these lofts, and instead of truncating our cube, we can just take these lofts. We can also take these scaled scaled squares. We can flatten it, well, because at this point we don't really care about data management. Well, we should always care about it, but in this particular point, it's quite uh, it's not crucial, let's say, because we need to put everything together and we need everything to be in one list. And as you can see, here is our truncated geometry, right? The Rombo truncated cuboctahedron, right? Yeah, and then if you want to see how, like, if you want to pick a more preferred aesthetics, you see basically here we're getting it almost as a cube. Basically, it's nothing more than a chamfered cube, and here it's almost yeah, cannot be zero. It still has to be a little bit present here. I'm not sure how this geometry is called exactly, but the topology of this geometry stays the same, right? Which means that the amount of points and the edges, whatever their connectivity, it's the same. Right. So this is our geometry. Now we need to create a supported geometry like this cube, right? So let's take it. Yeah, let's take it from one of these faces. So we can say because we don't know which face is going to be in this geometry, so let's just take one of these squares. So this item, right, like this, and let's extrude it. How do we make sure that we extrude it outwards? Well, we just take the center of this square. We take, yeah, we can extend it here. We say brep closest point, right? We take this brep and we take this point. By the way, guys, if I'm going too fast or if you missed something, please, or if you need to know the name of the plugin, please don't hesitate and ask me in the chat. I'm not promising to respond right away, but I will definitely do it after the session is finished. So please let me know if there are any questions about what we're doing here. Okay, so as you can see, we get this normal, right? And now we can say extrude, and we extrude this face, this face, we extrude it following this normal. And for the amplitude, we will take the length of the edge here. So again, say 0 edges, because we need to have a cube, right? So the extrusion distance has to be the same as the sides of this cube, right? So we just take this item, again we take length, and we connect it here. Voila, right? So we have it. Basically, this is our base geometry. So if we really know what we want to do, if we don't want to, if we just want to model this mesh that we would like to have, we can do as simple as just flatten first of all. Yeah, we can just bake this geometry and start copying it manually, right, to get this mesh. Not mesh, but like this geometry, which we will later on turn into a mesh. But if we would like to make it in a parametric way, if we're in a stage of testing, or if we would like to have more, or if we're building something more, maybe I saw some projects, some residential projects, which have of course, most of them were competitions, but I think there are some concepts and some projects which have similar topologies and similar shapes. So if you're making something like this, probably you need to be able to parameterize it completely. To put it short, let's try to build a rectangular array, actually a box array, consisting of these pieces of geometry. And we're going to connect this to the geometry, right? But I can already tell that it's not going to work like that. So it's going to be a bit tricky in terms of finding the cell size, right? Because right now, this geometry, like it's the bounding box of it cannot be a cell, right? Because basically we need this geometry to be interconnecting with another geometry which has the same dimensions and same shape, and another one, and so on. It's going to be a bit tricky. So this is the probably the most the trickiest part of today's script. Anyway, let's keep it as one for the moment, maybe two, just to see if the array works or not. And yeah, by default it doesn't work. You see it's overlapping, so I'm gonna drop it down to 1. And let's start thinking about the cell. So the cell has to be a box, right? But not a simple box. It has to have certain dimensions. So let's look at this thing and let's see how are we gonna make it. I'm gonna open up this piece. So what is the cell? What is the cell of this thing? Basically, the cell is the distance from center of this geometry to the center of this geometry, right? To the center of this geometry, to the center of this geometry, right? So basically, if we imagine the centroid of this thing, we draw a line to this thing, to this thing, and to this thing, and this is our cell, right? So how are we gonna make it? Well, basically we need to calculate the distance between the center of this geometry to the edge, right? So actually, let me check. So luckily, I saved this script for myself just to just to be able to have a look. Yes, so right. Okay, so maybe we will not use the array even. Maybe we'll just move it, right? Yeah, probably we'll just move it, which is also fine. How are we gonna move it? Basically, same way as I said. We can just take these. We can take these dimensions from these two geometries. So let's open up this thing again, and let's try to measure. Let's try to see the relation between this, for example, this box and this box, right? So the difference between the center from here, let's say the geometrical, not geometrical, the horizontal difference between one center and another center, basically is, yeah. Let's see. It's not half, right? It's basically this distance. Yeah, basically it's half of the square, and then the single single truncated face, right? So which practically means that for the x coordinate, um, yeah, yeah, for the x coordinate we have to move it by length of this distance, basically, right? So we say addition, and the x distance between these two things, which will be a second. So I always get confused with this dimension. Yeah, let's just take this. Let's deconstruct this bullet. Let's sort the size of the faces by area. Um, yeah, so that is. And we take the biggest one, right? Take the largest one from the end. Uh-huh. So yeah, you see basically this face, um, its height, right, is the same as the width of this one, right? Which means that we can literally take the bounding box for this geometry. We say deconstruct box. We say deconstruct domain, and we take the height, right? So let's say subtraction. We subtract the end from the start, and this is basically our distance, right? So then we say move like this, right? You see, yeah? Basically, this is the correct distance. Now we just need to move it up. And if we check, the height difference is basically going to be the same thing, right? So we say move, connect it to Z, and we hide this one. You see? Basically, this is how they are going to be organized, right? Okay, so now what we need to do, we just need to apply the same. Now, what we can do, we can create a series of these boxes, right? So we basically can merge it. right? And you can even say group for this one and for the other one. Promise guys, this is the trickiest part of the script. After that, it's going to be a lot easier, a lot more straightforward. Right, so we just made two of these, not to say much, two, right, so yeah, we make sure they are both in the same branch. And then we say move, right, and we can move it using series along x. And yes, we need to, yeah. But for the step, we need to use this number. You see, right? No, not this number, but no, this time it actually should be the entire distance. Anyway, um, so let's right here. You know what, guys? Actually, to not make it too complicated. Um, maybe we can just copy the points and then we just move this thing to the points. I think it's gonna be. I think this will be. Yeah, I think this will be a bit simpler. So let's say this is one of these parts, right? So we can just take the center. We can take the center of this geometry. Right? Um, right. So center. This is the distance of the. Plus, okay. Okay. Let's just make it like that. It's gonna be a bit easier. So yeah, let's try to build the framework of the points. So first point is going to be here, right? Another point is going to be yes. Okay, nice clear. So this the difference between the center of this set of geometry and this set of geometry, right, is basically the size of this box plus the length of this edge, right? So we take this center, not this center, but actually we can take the center of this box, which is this point, right? So let's take this point and let's take the y coordinate, y vector, right? And let's move this point along the y-axis. So we take the dimension of this number, right? What is it? here. Yeah, same number. We multiply it by 2. Actually, I'm gonna keep the group of this geometry, but I'm not gonna move this one. Okay, so we're not gonna move it. We're gonna group it, and then we're gonna move it afterwards. Yeah. So let's take this center. Let's multiply it by. Let's take this number, multiply it by 2, and let's add the let's add the length of this edge, which is here, right? This one. So yeah, this one here. Yeah, and let's create series. So we connect this to step, right? The start is 0. The count we can put it at 8, for example, maybe even less, right? And we move it along y-axis. Yeah, so you see. So now what we can do, we can say, we can say move to point, and we put this point as A, these points are as B, and this grouped geometry as geometry, right? So you see, basically now we're getting them in the right position along this axis, right? So what we need to do next? Next, we need to add more points along this how do you say? Yeah, along the x axis, right? So how does it work for x-axis? Well, this thing is here, then it gets moved here, right? So again, we need to move it along x-axis. We need to have the same step, right? So we say move, right, and we move all these things. We can apply we can put on, so we can say maybe I don't know, let's say 5. Doesn't really matter, guys. It's the same thing, right? And then we also need to graph it here. You see, right? And then we also have to put it along along the z-axis, right? And along the z-axis we have to put it following the same distance, basically, right? So it's also going to be same thing, right? So we also take uh, same same series. Maybe we can change the slider a bit, but for now it doesn't really matter. So we put it along like this. And here we have to say flatten, right? So we get this grid. There is a problem though, which I'm going to explain now. So you see, basically we're getting this grid, but we also need to have the same grid halfway, right? So how are we going to be getting it? Well, first of all, yeah, I'm going to hide these points because it's very heavy for my graphic card, especially if we are planning to increase these numbers. So first of all, I'm going to drop it a bit. And yeah, now what we need to do, we need to make sure we get another grid, which is, you see, basically, if I add more parts here, right? This, right? You see, this, and that. This is essentially our current grid, right? But we also need to have another grid here, right? This one, which basically goes halfway up and halfway to the right, right? So how are we gonna move this grid? Well, we need to say move, right? We need to move it along the x-axis, right? But this time, distance is going to be like we did it before. It's going to be this one, right? It's going to be this this let's say the width of this inclined face and the plus the length of this cube, right? So we're saying move. You see, right? This is the original one. This is the new one, and then we move it up by the same number, right? So we move it up by the same number. Right. Yep. Oh, right. So you see, we're getting our half grid here, right? This one, and then we need to get one more grid, right? So we can start merging them together. We can start merging this one and that one, right? And we need to get one more set of points, basically, which is in between these rows, which in turn is again moving it up halfway and moving it along the y-axis halfway, right? So basically we can take the same thing, and the only difference we need to do, the only difference is basically we take, instead of z-axis, we take y-axis here. Sorry, here, just like that, and we put it here. And we also need to second, so this one's left halfway. So this one here, yes, it's not here, and then x-axis here and here, here. So second, this is the row of points. Let's move up following the axis. Yes, so we need to do this one, right? And instead of moving it to the along the x-axis, we need to move it along the y-axis, right? So it's basically should be done like that, right? Um, here we go. Here we have it. Okay, so let me have this one. These are these points. Here they get moved forward, and then we need to move them. We don't need to move them along x-axis. We need to move them. Uh, yes, we need to move them here, and then we move them here. There we go. So now we're basically, yeah. Now we're ready to proceed. So let's say that we don't want all of these points to be we don't want all of these points to be occupied by one of these geometries, because it's going to be very heavy. So I'm going to draw a polyline, and I'm going to keep some of them here, right? So we can draw an attractor geometry. It can also be a point, it can be a polyline, doesn't really matter. Now I'm going to flatten all these points. We don't really care about data at this point. And then we say curve. We put this attractor geometry, right? And then we say pull point. So we use this curve as a attractor point, as a attractor geometry, and we are going to be calling all the points which are farther than certain distance. So let's say we are interested in the curves, in the points which are smaller, in the distances which are smaller than certain number. Let's say maybe 25, something like this, right? And we're going to be keeping only the points which follow this condition, right? Only these points. See? So, and after that, we basically take this move to point component. Actually, let me put the bifocals here so you can see the names of all the components we're using. And there we go. See? I actually see that we're missing one more grid here, right? Which is, well, which is supposed to be second. So if you switch to this mode. So okay, this is the base grid. This is the next one. We are getting this one, and we need to get one more, which is gonna go below. If I'm not mistaken. Yeah, let's try this one. Let's say we put it like that. So this is here, here, and then we put it below. So we say x, say minus x here. There we go. You see? So basically now we're kind of sorted, right? We have these pieces in place. Let's check if this hypothesis is correct. No. Um, no. It's not yet. Uh, Sorry guys, 1 second. Trying to find this. One moment. Let me check. Start here. So we got this one, the other one, and this one. This is the original grid, and we have to say x2, y2, and x5. Okay, I think I got it. So let's take the xyz vectors instead. Let's use this number, right? And let's take this. Yeah, I think this is gonna be probably a better move. Yeah, so let's take this one for xz. Let's flatten this. Let's copy it. Let's say xz, xy, and yz. So let's copy it like this. Yes, is it the anyway, let's connect it here and let's see how it looks. Seems to be okay. All right. So yeah, now it's fine. Let's proceed. I'm gonna group this thing and yeah, So it's going to be our tractor. So now we're getting to the fun part. We're going to be working with this mesh, right? So what are the techniques we're going to be looking at today? Well, we're going to be looking at how can we turn this pretty complex shape into a mesh, and how can we use the yeah, basically how are we going to use the um, how we're going to make it more organic and more because this is pretty geometrical, right? It's very solid, very yeah, very flat, and so on. So we're going to be making it a bit more organic. Let's first of all let's use the custom preview to see how it looks right now, and then we're going to start turning it into something more healing and more organic. So you see, this is like, well, pretty nice geometrical thing, but it's it's very it's very solid, right? Solid and flat. So what will be the way to turn it into something more organic? Oh, second, sorry, misclicked. Okay, so start. Let's start. Let's start joining it together, right? So we can say solid. We can first of all we need to ungroup it, right? Because we grouped it for easier transition from point to point, right? Then we need to say flatten. Because again, as I said before, in here we don't we just need to have a really solid single mesh. And now we say solid union, right? Again, as I said before, it's going to be a lot easier if you do it by hand, right? Because by hand you can just bake this geometry and put it together. Luckily, here it's also quite doesn't take that much time. I mean, still quite a lot, but not too much time, right? So it's quite okay, let's say. Okay, so now here starts the fun part. Let's deconstruct this brep, right? Let's say deconstruct brep. We deconstruct it into faces, right? And for each of these faces, each face is flat, right? So it's very convenient for us. It's also very good mesh. It's going to be a very good mesh because it's going to be completely flat. So now it's time for us to start dividing it into polygons, and there is one way we can do it. There are actually more than one ways to do it, but right now I'm going to show you the probably the simplest one. So let's take the areas, or we can also take, alternatively, we can take the polygon centers, because this thing is flat, right? So the polygon center basically represents the center of each of these faces, right? And let's take the edges, let's say brep edges again, right? For each of these faces, we take all the edges, all the naked edges. So you see, some faces, they have 4 edges, and some faces have 6 edges. So it means that we have to take these centers and we have to duplicate them um, as many times as the number of edges we have, right? So we say this length, and we use these numbers to duplicate this. We also have to graph it, right? Because each face basically becomes individual. We can also graph it here, actually. It's going to be even easier, probably. Right. And then now we have to graph this one, and we also have to take the end points of these edges for each of them, right? We can also say discontinuity, by the way, which is going to give us the tree. So now we can easily merge these points with these points. Let's check if they match. No, they don't. Why? Because we have to trim. Hold on a second, we have to. Yeah, I think we need to make this one principal. Make it principal. And in this case, yes. So you see, it's important to make sure that our data structures match. And this is actually the point where our data structure starts starts becoming really important for us, right? Because it's important that each phase is going to be connected with the corresponding points, right? So now we can make polylines from these points, right? And it's important to get the closed polylines, right? So each phase gets divided into triangles. And now we say boundary surfaces, right? Like this. So now we need a plugin which is called we need not a plugin, we need a component from a plugin. The component is called Simple Mesh, and Simple Mesh basically what it does, it turns every rectangle or every quad or every triangle into a mesh face, right? Now again we go to Weaverbird plugin. It's a very useful one for everyone working with meshes, so I highly recommend it when you download it. And we take the component called Weaverbirds join meshes and weld. Let's flatten it, let's weld it, and as a result, we're getting a very good closed mesh. I mean, it's not necessarily going to be closed if you use this plugin, but in this particular case, it's going to be closed, right? So let's go to shaded mode and let's go to display and let's see the mesh edges. So you see, we're getting quite a lot of them and quite a lot of these polygons, right? And I can also see that some of the faces, they have different orientation than others. So what we need to do, we need to say mesh unify normals, right? Like this. So you see, we have a unified mesh and it's a closed mesh, which is also really good for us, right? And now we can start actually making our mesh a bit more organic. So how we're gonna do it? Well, we're gonna take the first of all, let's take the let's go to Weaverbird and let's take the Weaverbird dual graph. There you go. See? So our mesh already gets a lot more organic, but this is not a mesh, right? This is just a set of polylines. So how can we make sure we turn it into a mesh? Well, you remember what we did here for the mesh edges, right? Basically, you do the same thing here. So let's take this very same part, right? Like we did here, and let's just copy it. Let's just copy it and let's connect it right after this dual graph thing. Probably it's gonna take a bit of time. Sorry guys, I think yeah, there was a bit of an issue. I did not draft it. So you should draft this. Yeah, you should draft this dual graph thing. Otherwise, it's gonna be yeah. Otherwise, it's gonna be that heavy. Um, yeah, well, happens sometimes. Maybe in the meantime, I'm gonna check the chat. So well, there hasn't been much questions. So yeah, maybe maybe guys, it's a good time to get some tea or some coffee, and we can be back in a couple of minutes. I'm gonna be here waiting for these two entries, but yeah, it's quite unfortunate that it happened, but anyway, happens sometimes. So um, Yeah, maybe we can start from here. Um, I'm not gonna close it. I'm just gonna open the file that yeah, the file that I worked before, that I worked with before, just so that we can move on. Because this is basically almost the end of the tutorial, so we didn't lose much. But yeah, I'm gonna show you how to. So basically, at really short, what we're gonna be talking about next is the ways to make the mesh more organic. And basically, we will need just the just mostly the Weaverbird plugin for it. And then I'm also going to show you some nice ways to paint your mesh. And it's not only for, let's say, it's not only for aesthetical purposes, but it's also for there are some printers, 3D printers, I mean, that can print your mesh with colors. I think it's the powder ones, which are they're quite expensive, but they're really give you the really high quality of the print, and they can also make it with colors. So if you would like to make your mesh to print your geometry with a gradient, or maybe to print it with some textures or whatever, I would say this is a really nice way to go. And yeah, I'm going to show you how to make these gradients and how to color your mesh properly. So um, I mean, yeah, you can color it for various reasons, from purely aesthetical to sometimes you can. Okay, yeah, so here we go. Yeah, so right, we cannot copy this part completely because we need to clear at edges. But anyway, so first of all, I'm gonna delete this part. Yeah. Let's take this part again. First of all, let me save the file actually. Today's date is 5th November. Yeah. So, still, I'm gonna try to copy this part, but instead of taking the B-rep edges, we're gonna be working with these polylines, right? So first of all, let's graph it so that each polyline becomes an independent polyline, right? So it's not, yeah, so it's not just a list, it becomes a tree, right? And then what we need to do, we need to find the center of these polylines. So we take yeah, I'm just going to take the polygon center, and we cannot calculate the area for these polygons, so I'm going to take the central vertex, right, the average vertex, and then I'm going to say explode the polyline, right? I'm gonna do the same thing. I'm gonna take the discontinuity of it, right? So we take this thing. Here we take disable for the moment. We take the center, and here we take the segment, right? And what happens now is now we're getting this thing a lot more dense, right? Also, we're building the polylines, right? And on these polylines, we're building the boundary surfaces. So you see, right? So what is important for us right now is having these centers, right? I'm gonna create a separate container for these points, because these are the points which are gonna be the deep parts of our mesh. They're gonna go inwards, right? So, and it's important for us to have the appropriate color and for yeah, for basically rebuilding our mesh. So you see, this is our new mesh, right? Looks very organic, very smooth. But what we will be trying to do is sorry, we will be trying to get it first of all, we're going to be getting it in colors, right? But wow, this is a bit, yeah, it's kind of okay. But next thing we're going to be doing, we're going to be making it uh, go inwards, inside. So, all right. Actually, is it a closed mesh? No, it's not. Interesting. Why is it not closed? Should be closed. Anyway, let's see. Changes. Where are the naked edges? So when you need to check, oh wow, there's quite a lot of them. So maybe what we need to do, we need to say weld mesh vertices. This should probably help. Um, just a few. Okay, this is already a lot better, and this part is probably yeah, I see. I see. So why did it happen? Um, well, yeah, sometimes it happens. Sometimes it's this. What can we do about it? There's not much we can do about it actually. We can just what we can try to do in this case. We can either, of course, we can always fix it manually by putting an appropriate cube here. Otherwise, we can also just move some points to get get a different or a better shape, which is also an option, right? So sometimes it helps us to fix it. That's not the case, but anyway, for now, it doesn't really matter if our mesh is closed or not. Of course, it's better if it is, but we can fix it later. You know? So yeah, what I was gonna show, I was gonna show you how to make this mesh um, with these nice how do you call it, like cavities, and to make it a bit more organic. So let's say yeah, let's say deconstruct mesh, and let's take the 2 point component. We take these vertices as points. We take these points as I'm actually going to flatten them because we want all to be in the same branch. I'm going to use them as attractor geometry, right? And then we say move, right? So we move all these points with a certain amplitude. Let's control this amplitude by a slider. We can either use absolute values or we can use a factor of some length in this geometry. Let's take these normals, right? Yeah. So, and then we say construct mesh. So we use these as vertices, this thing as faces, and we connect it here. So, um, yes, I want it to go outward. Sorry, inwards. So we make it better. Okay, this is probably a bit too much. Let's say we make it like that. Yeah, right. So we need to use the distance. We need to remap the distance. So take the bounds, and we say we connect this to the amplitude, and we need to have the domain. We need to say construct domain, and we will make it start from 0 to the opposite. The closer the point to this center, the more it should move. Right. So yeah, there we go. What happens if I increase it? Okay. So this is one way to do it. Another way will be to first subdivide this mesh a bit more. So we can do it with Weaverbird. We can say Catmull Clark subdivision, like this one. Connect it here. It will be 4 times slower because we get 4 times more vertices, even more, even slower. Yeah, and then we connect this thing. This is the mesh. Good. There are a lot of these points here. Yeah, we should not move these points. We should move these vertices. Yes. There we go. There we go. So you see, we're getting this mesh like that. You see? So, in my opinion, I mean, I'm not saying this is like something super beautiful or whatever, but in my opinion, the client was quite happy with the result for this corals, right? I think it looks quite a nice mineral. So anyway, we can control the amount of this motion to a certain extent, of course, because at some point this meshes will start intersecting itself. In this case, we need to go back a bit. We can also do the opposite. We can also go move out if we're looking for something like that, right? Which is also an option. And I personally saw some projects which were some projects for these artificial coral reefs. I'm pretty sure you've seen them. Also looks like some vegetable to me. But anyway, yeah. So the point was to show you how to control this deformation, how to make this pseudo aggregated organic mesh. And now, last thing I wanted to show you is actually how to. First of all, yeah, thanks to everyone who followed all the way and who stayed with me today. And I'm going to show you how to apply some color coding and some colors to this mesh. Because as you can see, right now it's just the normals, right? Just the just the normals have changed in the shape, which is a bit different. How can we paint it? So there are two ways we can do it. I'm going to show you first of them, which is the gradient, right? I have already prepared a few presets. Actually, I might take this gradient I'm doing it here, right? Because I like these colors. And I'm not gonna go do something very special. I'm just gonna I'm gonna add it to the presets. What I'm gonna do, I'm gonna use these gradients for the colors, right? So let's take this domain, is the domain of distances, right? Let's say deconstruct domain. This with T, this with L0, L1. And let's connect these to colors here, right? You see? I'm sorry for people who have trypophobia or trypophobic. This looks quite scary probably, but yeah, I'm gonna. I mean, I personally like it, but I'm sorry if you find it scary. But yeah, we can also do the opposite. We can also do something like this, which makes it a bit more friendly, or just like that. It's actually nice. Maybe we can also invert it, right? So it gets this. So my point here is that we can be using. Oh, this is actually nice. My point is that we can be using these gradients as a way to how do you call it, to underline, let's say, the shape of your mesh to make it look even more pronounced, even more visible than just the geometry itself. Or we can also use it to mask it, like a camouflage, let's say, right? I can set it like this, maybe this one. Yeah, I don't know. I personally really like this one, but yeah, I understand it also can look a bit scary. Anyway, so this was one way to do it. Another way to do it will be to, oh, sorry, oops. I'm gonna disconnect it for now. Another way to do this is to actually use an image to assign the texture to this mesh, right? So how can we do it? Well, we can do it with the help of an image sampler. I'm pretty sure I have already shown you a few tutorials with this component, but still keeps working pretty well. So I thought, why not? Let's take this image. Let's you can also take any grunge texture or literally any texture, right? And we're going to be using this as a color for our mesh. Also, let me know if you're interested in more color related tutorials, because I might be showing a tutorial on dividing your texture, your image into like tiling it or turning it into mosaic or into stained glass in Grasshopper, like in a parametric way. So basically, you can take an image and turn it into a stained glass or like administration. Let me know if you are interested. I will make a tutorial about that. But today we're gonna go with a simplified version of it. So let's take this mesh, right? Let's take the bounding rectangle. It works even if your geometry is not flat. You just need to provide the plane, right? We're gonna turn it into a boundary surface, boundary surfaces, right? And I'm gonna divide this surface into many parts. So let's see the dimensions of the surface. It's very simple. So I'm going a bit faster, but yeah, you can see that this number it's almost a square, right? So you can say division. Also depends on the actually we don't even need to divide it. Actually, we just need to take this surface. We need to take these vertices, right? We say surface closest point. In this case, these points are going to be projected on the surface as like following the normals, right? So it's basically the color of this mesh is going to be dependent on its location against this surface. So again, we take the UV parameter, connect it here, right? And we say as a result we get the colors. See? And now if we want to paint this thing accordingly, see, these are basically the colors. What is important to do is to check if this is interpolate, yes, or the brightness. You can also do the brightness. Well, let's do it as an interpolation. So you see, we have the same number of vertices here as the amount of colors, right? So each of these vertices, it has its own coordinate, its own color, right? So it's kind of works. Uh, One more thing that I was going to show you. Yeah, 1 second. Yes. So one more thing I wanted to show. Yeah, 1 second. Sorry. I think I forgot to reparameterize the surface. Yes. So that was the problem. So you see, when your domain has to be from 0 to 1, otherwise image sampler is not going to work correctly. So we need to reparameterize the surface. So you see now, basically, it takes the colors and the shades of this texture. And I think this, at least for me, this already looks quite convincing as a photo, right? Even if we're talking about some sort of video games or things like that, or landscape in your renders, this can work as a texture, as a surroundings or as geometry quite well. Yeah. Last thing I wanted to show you is how can we get a twin between these two values, right? How can we make our texture not only as a gradient, but also as this texture? How can we merge them? So you see here as the output, we're getting a lot of, to be precise, we're getting 28,936 colors, and here we're getting the same amount of colors. So how can we, let's say, um, how can we merge them together? Well, there is a plugin called Pufferfish, which can be downloaded from Fit4Rhino. It's an amazing plugin. I use it all the time, and it has a really nice, really useful component which is called Twin Two Colors. So let's connect the gradient colors as A and the colors in the texture as B, right? And let's connect their twin to the colors. So you see now, not only we get this really scary colored mesh, but we're also getting some gradient on the outer side of it, right? So let's alter the factor, because right now it's 0.5. Let's take the, if we take the 0, it just becomes this scary gradient. If we make it more, right, it gets closer to our texture. So you see that we can get a texture which basically did not exist before. We're kind of altering our texture, so we don't need Photoshop to alter. I mean, of course, we can adjust this texture in Photoshop quite a lot, but if we need to change the color, we can use this method, right? So if we need to make it a bit more greenish, more bluish, right? For example, if I don't want to have this gradient, if I just want to make it more purple, you see, I can just add this color, and you see, with these colors we can control the saturation, we can control the color of our texture, right? So density and so on and so forth, right? So yeah, right, and there's possibilities, and it's not only aesthetical. It's you can also print this texture, and you can also have your design with this texture if you're using that 3D printer I mentioned before. So yeah, of course we can also apply the cat multiplier. Yeah, another really good thing about this thing about the colors is that if you apply the cat multiplier after you already applied all the colors, it doesn't turn the mesh into a white thing again, right? It just smoothens it, and it interpolates these colors of the neighboring vertices, right? So it gets really it really like follows the initial color mapping, right? And you can also use the I think it's called color. Sorry, it's called mesh blur or something like this. I don't remember the name, but yes, blur mesh. This one. So you apply it to a mesh, and it makes the transition even smoother, right? So it might be important if you're planning to print it, to 3D print it. If not, it still gives a slightly better visual result in the end, right? So it gets a bit nicer. Let's see, we can make it more or less colored. Yeah. So you can also I also create some of I also create some of the gradients myself. I personally really like this one, but yeah, there are also endless possibilities to make your own presets. Right? So you can also, this one is a bit funny, but anyway. Okay, so I think that's it for today. Thank you to everyone who stayed here. I hope it was useful and interesting for you. I also hope to make more tutorials soon. Please comment. Let me know what you would like me to tell about next time. We're collecting all the requests and all the questions, and we try to make more tutorials about them. As I mentioned before, also check our Kinetic script and models design market if you would like to support us and to help us make more content. And yeah, we also have an Instagram page. So if you're looking for if you want to get a course, or if you want to get featured or whatever, please drop us a message. We also read them and respond quite on time, let's say. Thank you, everyone. Have a nice week ahead, and see you next time. Bye.